Alright, let's look at the homework 7.9-8.1, problem number 1. Alright, so we want to evaluate this double integral over the semicircle bounded by y equals square root of 4 minus x squared and y equals 0, which is the x-axis. Alright, so let's do that. Alright, first we want to sketch the region. So that's going to be a semicircle, so it's going to be here. Here's the x-axis, and here's the y-axis right in the middle, right? So since this is 4, so this is a radius squared, so radius is 2, right? So here's y. So it's going to go through 2 here, positive 2, and on the other side, negative 2, and that's going to be positive 2, right? So the semicircle is going to look somewhat like this. Alright, so we're looking at the region here. Alright, so y equals 0 is the x-axis, so which is the bottom one. Right? So this is the region. Alright, so we just have to set up the integral. So integral is going to look like, so I'm going to just go here. Right? So this is going to be an integral, double integral here, x, and I'll probably do with respect to y first, and with respect to x, right? Right, since the second integral is with respect to x, I'm going to fix x, then try to see where this segment starts and ends, right? So this guy starts from y equals 0, because it starts from the x-axis. And this is right on the circle, which has the equation square root of 4 minus x squared, right? So the lower limit is y equals 0. The upper limit is y equals square root of 4 minus x squared, right? Then in order to cover the entire region, right, it's going to start from negative 2 and then go all the way to, so you can see that a bunch of line segments, and go all the way to x equals 2. So here's x equals 2 and x equals negative 2, right? So integral is going to go from y equals negative 2 to, sorry, not y equals 2, it's x equals 2. X equals 2, negative 2 to positive 2. Alright, so let's do that. So if you do the inside, since this is with respect to y, we can kick the x, since it's a constant, outside the integral. Right? So you can see that this is going to be integral from x equals negative 2 to x equals to 2, right? Then you have an x, right? Then it's going to be, since x is outside, it's an antiderivative 1 with respect to y, which is going to be just y. Then you're going from 0 to y equals square root of 4 minus x squared. Then with respect to x, right? So this is going to look like this, integral from negative 2 to positive 2, right? If you plug in square root of 4 minus x squared and a minus 0, so you're just going to get the x square root of 4 minus x squared dx. All right, so one way you can do is this is the slickest way. If you see that this is an odd function, then if you integrate the odd function from negative a to positive a, the answer is going to be 0, right? So we've done that before. So I'm going to actually try to do a substitution to see if we can get a 0 as well. All right, so blindly, let's do a substitution here. All right, let u be 4 minus x squared, right? Then you can take the derivative of u, du over dx, is equal to negative 2x. And then take the reciprocal of both sides, dx over du, which is going to be 1 over negative 2x. Then multiply both sides by du. We get the dx is equal to du over negative 2x, right? Then we have to change the lower limit and upper limit. So x originally goes from negative 2 to positive 2, right? But the u is going to be, plug in negative 2 here. 4 minus negative 2 squared would be 4 minus 4. It's going to be 0. And 4 minus 2 squared would be 0. So you can see that this is going from 0 to 0, right? Then x, and here the expression inside the square root is u, so we have a square root of u, right? Dx is, we found that to be du over negative 2x, right? So we can cancel x and x, and you have a negative 2 on the bottom. So if you want, we can put negative 1/2 outside. Integral from 0 to 0, square root of u du, right? But if the integral is from going from 0 to 0, integral is 0, so therefore this is going to be 0, right? So you can see that without using the, the fact that this is an odd function, we can still get the same answer. All right, that's it. I hope that this was clear.